One of the benefits of using TypeScript is its strong typing. Every property has a type, every method has a return type, and every method parameter has a type. This strong typing helps minimize errors through better syntax checking and tooling. In some cases, however, we have a property or method that does not have a predefined type, such as our products array here. We defined our products array as any, which negates the benefits of strong typing. To specify custom types, we can define an interface. An interface is a specification identifying a related set of properties and methods. A class commits to supporting the specification by implementing the interface. That means the class includes code for each property and method identified in the interface. We can then use the interface as a data type. ES5 and ES 2015 do not support interfaces, but TypeScript does. So interfaces are transpiled out and are not found in the resulting JavaScript. This means that interfaces are development time only. Their purpose is to provide strong typing and better tooling support as we build, debug, and maintain our code. Here is an example of a TypeScript interface. We define an interface using the interface keyword, followed by the interface name, which is often the name of the business object that the interface describes. By many naming conventions, the interface is prefixed with an I for interface, though some TypeScript developers leave off this prefix. The export keyword here at the front exports this interface, thereby making it available for use anywhere in the application. The body of the interface defines the set of properties and methods appropriate for this business object. For each property, the interface includes the property name, a colon, and the property data type. For each method, the interface includes the method name, the list of parameters along with their data types, a colon, and the method return type. To use the interface as a data type, we import the interface, then use the interface name as the data type. Looks easy enough. Let's try it out. We are back in the sample application looking at the product list component. Here we see that we defined our products array as any. So let's create an interface that defines what a product is. We'll put the interface into its own file in the products folder. We'll name that file product.ts after the business object it defines. We first type the export keyword to ensure the other parts of the application can use this interface. That is, after all, why we are creating it. Next, we type in the interface keyword, then the name of the interface. I like to use the I prefix to distinguish the interface from the business object, and we are defining a product, so I product. Inside the interface, we define the properties and methods appropriate for the business object. For our sample application, we only need properties. For each property, we define the property name, a colon, and the type of the property. Notice that we are typing the release date as a string. If we later work with this value as a date object, we could change this type to a date. That's it. That's all we have to do to define an interface. Now we can use this interface as our data type in the product list component. Before we do, though, let's try something. Let's introduce a typographical error into our products array. No error is detected. We won't even know we made a mistake until we see the application in the browser. And we notice that no image is displayed for one of the products. As you can imagine, these kinds of errors could cause hard-to-find bugs. Now let's replace the any with iProduct. We get a syntax error. What did we miss? Yep, we need an import. And bang! Now that our array of products is strongly typed, we are notified that we made an error in our product array property. We don't even have to view it in the browser to see that something is amiss. So this is a good demonstration of one of the benefits of strong typing. Let's fix that error. Notice that we get IntelliSense now for these properties, another great benefit of strong typing. Let's check this out in the browser. Now everything works as it did. In our interface file, we could define a class for the product business object here as well. Something like this. In general, we only create a business object class if that class provides some functionality that we want to use throughout our application, such as this calculate discount method. And if we think we might want to create a business object at some point in the future, then we definitely want to add the I prefix to our interface. But for our sample application, we don't need any product methods, so we don't really need a product class. We will use this interface throughout the application to strongly type our products. Before we move on, let's make one change. Notice that we're getting lots of files here. Unless we want to look at them, we really don't need to open the .js or .map files. Let's hide them from the editor. In VS Code, we do that by selecting File, Preferences, Workspace Settings. I'll paste exclude entries for the .js and .map files. Now we see that the .js and .map files don't appear in the Explorer window here on the left, and we can more easily find the files we need to edit. Neat! Next, let's look at encapsulating component styles. When we build a template for a component, we sometimes need styles unique to that template. For example, if we build a sidebar navigation component, we may want special li or div element styles. When we nest a component that requires special styles within a container component, we need a way to bring in those unique styles. One option is to define those styles directly in the template's HTML, but that makes it harder to see, reuse, and maintain those styles. Another option is to define the styles in an external style sheet. That makes them easier to maintain, but that puts the burden on the container component to ensure the external style sheet is linked in the index.html. That makes our nested component somewhat more difficult to reuse. But there is a better way. To help us out with this issue, the component decorator has properties to encapsulate styles as part of the component definition. These properties are styles and style URLs. We add unique styles directly to the component using the styles property. This property is an array, so we can add multiple styles separated by commas. A better solution is to create one or more external style sheets and identify them with the style URLs property. This property is an array, so we can add multiple style sheets separated by commas. By encapsulating the styles within the component, any defined selectors or style classes are only applicable to the component's template and won't leak out into any other part of the application. Let's try this out. Before we change any code, let's look again at our product list view in the browser. Notice the table headers. They could use a little color, so let's build an external style sheet for our product list component. We'll add a new file in the Products folder, and since this file only contains the styles for our product list component, we'll call it product-list.component.css. In this style sheet, we add a table header style. We can modify the t-head element styles directly because the style sheet is encapsulated in this component, and the styles defined here won't affect any other component in the application. We could add any other styles as needed to jazz up our product list component. To use this new style sheet, we modify the product list component. In the component decorator, we specify our unique style sheet. We add the style URLs property and pass it an array. In the first element of the array, we specify the path to our style sheet. Note that the style path is relative to the index.html file. We could add more style sheets here, separated with commas. Let's review the result in the browser. And we see that the table header is now a nice blue color. We can use the styles or style URLs property of the component decorator anytime we want to encapsulate unique styles for our component. Next up, let's dive into lifecycle hooks. A component has a life cycle managed by Angular. Angular creates the component, renders it, creates and renders its children, processes changes when its data-bound properties change, and then destroys it before removing its template from the DOM. Angular provides a set of lifecycle hooks we can use to tap into this lifecycle and perform operations as needed. Since this is a Getting Started course, we'll limit our focus to the 3 most commonly used lifecycle hooks. Use the onInit lifecycle hook to perform any component initialization after Angular has initialized the data-bound properties. This is a good place to retrieve the data for the template from a back-end service, as we'll see later in this course. Use the onChanges lifecycle hook to perform any action after Angular sets data-bound input properties. We have not yet covered input properties. We'll see those in the next module. Use the onDestroy lifecycle hook to perform any cleanup before Angular destroys the component. To use a lifecycle hook, we implement the lifecycle hook interface. We talked about interfaces earlier in this module. Since Angular itself is written in TypeScript, it provides several interfaces we can implement, including one interface for each lifecycle hook. For example, the interface for the onInit lifecycle hook is onInit. Notice that it is not prefixed with an I. We are using the onInit interface from Angular, so any guesses as to our next step? Yep, we need to import the lifecycle hook interface. We can then write the hook method. Each lifecycle hook interface defines one method whose name is the interface name prefixed with ng for Angular. For example, the onInit interface hook method is named ng onInit. Our first step here of implementing the interface is actually optional. Recall from our discussion of interfaces earlier in this module that neither ES5 nor ES 2015 support interfaces. They are features of TypeScript. That means that the interfaces are transpiled out of the resulting JavaScript. So we don't really have to implement the interface to use lifecycle hooks. We can simply write code for the hook method. However, it is good practice and provides better tooling when we implement the interface. At this point in our application, we don't need to implement any lifecycle hooks, but we'll use them in later modules. So let's try them out now. We are looking at the product list component. We'll add the onInit lifecycle hook to this component. First, we implement the interface by adding it to the class signature. Type implements and the name of the interface, onInit. The interface name is showing an error, and we know why. We don't have the import. Let's add that now. Since onInit is also imported from Angular 2 Core, we simply add it to our first import statement by typing a comma and onInit. Now we have another syntax error here. Class product list component incorrectly implements interface onInit. As the message states, now that we've implemented the interface, we must write code for every property and method in that interface. The ng-onInit interface only defines one method, ng-onInit, so we need to write the code for the ng-onInit method. We'll add it down here by the other methods. Since we don't really need to do anything with this event at this point, we'll just use console.log to log a message to the console. We can view the application in the browser and use the F12 developer tools to open the console and view the logged message. We can see our message here. We'll use ng-onInit later in this course. Up next, we'll build a custom pipe. As we saw in the last module, we use pipes for transforming bound properties before displaying them in a view. There are built-in pipes that transform a single value or an iterable list of data. We covered these in the last module. In this module, we want to build our own custom pipe. The code required to build a custom pipe may look somewhat familiar at this point. It uses patterns similar to other code we've created in this course. Here is the class. We implement a pipe transform interface, which has one method, transform. We write code in the transform method to transform a value and return it. The first parameter of the transform method is the value we are transforming. In this example, we transform an array of products into a filtered array of products. Notice that we are using the iProduct interface to strongly type the array that's passed in. That is the interface we created earlier in this module. The second parameter here is for any arguments we need to perform the transformation. In our case, we want to pass in the filter criteria entered by the user. The method return type is also defined as an array of products because we are returning the filtered array of products. We add a pipe decorator to the class to define it as a pipe. Similar to the other decorators we've used, this is a function, so we add parentheses. We pass an object to the function specifying the name of the pipe. This is the name for the pipe used in the template, as we'll see shortly. And of course, we have our imports to import what we need. Notice how similar this looks to the components we've created in this course? Angular provides a very consistent coding experience. To use a custom pipe in a template, simply add a pipe and the pipe name. Include any arguments required by the transformation separated by colons. But of course, that is not enough. We also need to tell Angular where to find this pipe. So in the templates component, we add a pipes property and define an array of all of the pipes used by the template. Notice how similar this is to the directives property that defines the list of directives used by the template. And the last step? Yep, we need to import the pipe. Now let's build our custom pipe and filter our list of products. Since our custom pipe is currently designed to only filter products, we'll add it to the products folder. We'll create a new file and call it product-filter.pipe.ts, following our naming conventions. We'll start by writing the code for the class. Export so we can import this pipe where we need it, class, and the class name. We'll call it product-filter-pipe. We want to implement the pipe transform interface, so we add that here. The syntax error is because we don't have the import statement, so let's add that next. We still have a syntax error because when we implement the pipe transform interface, we are required to implement every property and method defined in that interface. For the pipe transform interface, there is only one method, transform. Notice right away that we have yet another syntax error. We are defining the value parameter to be an array of iProduct, but we have not yet imported that interface. So let's do that now. And we can add a return statement to get rid of this last syntax error. Next, we need to decorate the class with the pipe decorator. Here we specify the pipe's name, and we'll add pipe to our import statement. Now it's time to implement the transform method. I'll paste the code so that we can talk through it. But don't worry if you haven't seen some of this syntax before. This is mostly JavaScript and is not critical for learning Angular. But what does this code do? Our goal is to transform the passed-in list of products to a filtered list based on a user-entered filter string. That filter string is passed into this method in the args array. So this first line of code pulls that filter string from the first element of this array. We again use a JavaScript conditional operator to handle the possibility that there is no value in the first element. We then convert the filter string to lowercase. Why convert it to lowercase? So we can compare apples to apples when we filter the product list. We want a case-insensitive comparison. Then we return the filtered list of products. Let's break this down. This code also uses the JavaScript conditional operator. If our filter variable has a true value, meaning that it is defined and not null, then we filter the list. Otherwise, there was no filter specified, and we return the original value, which is our full list of products. Let's look closer at this filter statement. We are using the array filter method to create a new array with elements that pass the test defined in the provided function. We're using the ES 2015 arrow syntax to define that filter function. For each product in the list, the product name is converted to lowercase, and the index of is used to determine if the filtered text is found in the product name. If so, the element is added to the filtered list. See the MDN entry for filter at this link for more information on the array filter function. Now we are ready to use our pipe in the product list component. We'll filter the list of products here. In our NG4 clause, we'll add the pipe character and the name of our pipe, product filter. Be sure to insert it within the quotes. We also need to pass in our pipe argument. In this example, we pass in the list filter property. That property contains the value the user entered in the filter by input box. Now that we've used this pipe in the component's template, we need to tell the component where to find this pipe. We do that by adding a pipe's property to the component directive metadata. And we import the product filter pipe. Are we ready to see the result? Our default filter is cart, so now we only see the garden cart. Change the filter, and we see different entries. It's working. Not too shabby. Not too shabby at all. So to create a custom pipe, we built a class, implemented the pipe transform interface, and decorated the class with the pipe decorator. To use the pipe in a template, we specify a pipe character, the pipe name, and any pipe arguments. In the template's component, we define the list of pipes as part of the component decorator. Let's finish up this module with some checklists we can use as we work more with components. We covered 4 discrete topics in this module, so we have a checklist for each one. First, interfaces. We use interfaces to specify custom types, such as product in our sample application. Interfaces are a great way to promote strong typing in our applications. When creating an interface, use the interface keyword. In the body of the interface, define the appropriate properties and methods along with their types. And don't forget to export the interface so it can be used anywhere in our application. We implement an interface, including built-in Angular interfaces, to ensure that our class defines every property and method identified in that interface. Add the implement's keyword and the interface name to the class signature. Then be sure to write code for every property and method in the interface. Otherwise, TypeScript displays a syntax error. We can encapsulate the styles for our component in the component itself. That way, the styles required for the component are associated with the component alone and don't leak into any other parts of the application. Use the styles property of the component decorator to specify the template styles as an array of strings. Use the style URLs property of the component decorator to identify an array of external stylesheet paths. The specified styles are then encapsulated in the component. Lifecycle hooks allow us to tap into a component's lifecycle to perform operations. The steps for using a lifecycle hook are: import the lifecycle hook interface, implement the lifecycle hook interface in the component class. This step is not required but highly recommended. Then write the code for the hook method defined in the lifecycle hook interface. To build a custom pipe, import pipe and pipe transform. Create a class that implements the pipe transform interface. This interface has one method, transform. Be sure to export the class so the pipe can be imported from other components. Write code in the transform method to perform the needed transformation, and decorate the class with the pipe decorator. We can use a custom pipe in any template anywhere we can specify a pipe. Immediately after the property to transform, type a pipe character, specify the pipe name, and enter the pipe arguments, if any, separated by colons. In the templates component, import the pipe. In the metadata, add the pipe's property and provide an array defining the custom pipes used in the template. This module provided a set of techniques for improving our components. We walked through how to use an interface to strongly type our custom objects. We saw how to encapsulate styles within a component. We were introduced to the component lifecycle and how to tap into that lifecycle with lifecycle hooks. and we discovered how to build a custom pipe that we can use in any component template. So in this module, we've completed the product list component. Yay! Next up, we'll see how to build nested components, and build design may include features. Here is a visual representation of a component that is nestable. Here is another component. It wants to use the nestable component in its template. We then refer to the outer component as the container or parent component, and we refer to the inner component as the nested or child component. When building an interactive application, the nested component often needs to communicate with its container. The nested component receives information from its container using input properties, and the nested component outputs information back to its container by raising events. In our sample application, we want to change the display of the 5-star rating from this to this. Displaying the rating number using a visual representation, such as stars, makes it quicker and easier for the user to interpret the meaning of the number. This is the nested component we'll build in this module. For the star component to display the correct number of stars, the container must provide the rating number to our star component as an input. And if the user clicks on the stars, we want to raise an event to notify the container. Let's jump right in and build our star component. When we last saw our sample application, we had completed the product list component. Now, of course, we want to change it. Instead of displaying a number for the rating here, we want to display stars. Instead of adding the code to the product list component to display the stars, we want to build it as a separate component. This keeps the template and logic for that feature encapsulated and makes it reusable. So let's begin by creating a star component. The star component can be used by any feature of the application, so it really doesn't belong in our products folder. We'll instead put it in a shared folder where we'll put all our shared components. If you are using the starter files, I've already created this folder and included the template and style sheet for our component here. Now we are ready to build the star component. We begin by creating a new file. We'll name it star.component.ts. We then create this component just like we'd create any other component, starting with the class. Export class star component. What's next? Yep, we decorate the class with the component decorator. Recall that it is this component decorator that makes this class a component. As always, it shows us a syntax error here because we are missing, yep, our import. Now we are ready to set the component decorator properties. For the selector, we don't want to use the PM prefix because this component could be reused anywhere in our company, not just in the product management application. We'll instead prefix the selector with an abbreviation for our company, which in this case is AI for Acme Inc. For the template URL, we provide the path to the HTML file provided in the starter files. We add the style URLs property, and in the array we'll set the first element to the path of the style sheet that was also provided. Now let's take a peek at the star component template. Here it displays 5 stars. It then crops the stars based on a defined width. This technique can then display partial stars, such as 4.5 of the 5 stars, by setting the width such that only 4.5 of the stars appear. Recall what this syntax is called? This is property binding. We're using it here to set the style width, and here to bind the title property to display the numeric rating value. For these bindings to work, we need 2 properties in the components class, the rating and the star width. Let's add these 2 properties. We want a rating property, which is a number and defines the rating value. Since we don't yet have a way to get this value, let's hard-code it to 4 for now so we'll see some stars. And we need the star width. This value is calculated based on the rating. So where do we put that calculation? Well, We'd want the star width recalculated anytime the container changed the rating number. So let's tap into the onChanges lifecycle hook as we discussed in the last module. We'll add onChanges to the import statement. We'll implement the onChanges interface, and we'll write code for the ng onChanges method identified in the onChanges interface. In this method, we'll convert the rating number to a star width based on the width of our stars. Our component is now complete, and we're ready to nest it in another component. How do we do that? Now we are ready to nest our new component within another component. We do that by using our nested component as a directive and following the same steps we covered earlier in this course. Here is a shortened form of the code for a container component and its template. And here is the nested component we just created. Instead of displaying the star rating number, we want to display the stars. So the container component uses the nested component by specifying its directive here. This identifies where in the container to place the nested component's template. And the directives property in the product list component metadata defines where to find the directives component. Let's jump right back to our demo. Our star component is now shown here on the right. We want to use our star component in the product list template that is here on the left. In the table data element, we want to replace the display of the star rating number with our star component. To do that, we simply replace the binding with our AI star directive. Now our product list template will display our stars here. Next, we'll need to update the template's component, so let's open that to the right. We need to tell the template's component where to find this AI star directive. We'll first add the import for the star component. Then we'll add the directives property to the object passed into the component decorator. Recall that the directives property is an array, so we pass star component in as the first element of the array. And since we imported the component first, IntelliSense helps us here. These are the same steps we followed earlier in this course to use a component as a directive. Nothing new here so far. Let's see what we did. We have stars, yes! But we see 5 of them. Let's clear out the filter. Yes, we see 5 every time. Hover over the stars, and we see our hard-coded star rating is 4. It seems that our star width is not being set. Let's look at the code again. We set the star width property in the ng onChanges method when the onChanges lifecycle event occurs. But the onChanges lifecycle event never occurs because onChanges only watches for changes to input properties. We don't have any input properties. So we have 2 problems here. Our onChanges event does not fire, and we don't currently have a way to get the correct rating number from the container. Let's see how input properties can solve both of these issues. If a nested component wants to receive input from its container, it must expose a property to that container. The nested component exposes a property it can use to receive input from its container using the aptly named input decorator. We use the input decorator to decorate any property in the nested components class. This works with any property type, including an object. In this example, we want the rating number passed into the nested component, so we mark that property with the input decorator. The container component then passes data to the nested component by setting this property with property binding. When using property binding, we enclose the binding target in square brackets. We set the binding source to the data that the container wants to pass to the nested component. In this example, the product list template passes the product's star rating number. The only time we can specify a nested component's property as a property binding target on the left side of an equals is when that property is decorated with the input decorator. So in this example, The product list template can bind to the rating, but not the star width. Let's give this a try. Going back to our star component, let's add input to our import statement, because we know we're going to need it. The star component wants to expose the rating property to its container, so the container can provide the rating number. We'll add the input decorator then to the rating property. The input decorator is a function, so we add parentheses. We don't need to pass anything to this function, so that's it. And let's remove this default value. Now that we can get the value from the container, we don't need that here. In our example, we decorate only one property of the nested component with the input decorator, but we are not limited to one. We can expose multiple input properties as needed. In the containers template, we use property binding and define the nested component's input property as the target of the binding. Then we set the binding source to the value we want to pass into the nested component. In this example, we pass the product's star rating. That's it. The product star rating property is now bound to the rating input property of the nested component. Anytime the container data changes, the onChanges lifecycle event is generated and the star width is recalculated. The appropriate number of stars are then displayed. Let's check it out in the browser. That looks better. Well, we're not really displaying the 0.2 stars here. Our algorithm could use some improvement, but you get the idea. But what if we want to send data back from our nested component to our container? Let's look at that next. We just saw how the container passes data to the nested component by binding to a nested component property that is decorated with the input decorator. If the nested component wants to send information back to its container, it can raise an event. The nested component exposes an event it can use to pass output to its container using the aptly named output decorator. We can use the output decorator to decorate any property of the nested components class. However, the property type must be an event. The only way a nested component can pass data back to its container is with an event. The data to pass becomes the event payload. In Angular, an event is defined with an event emitter object. So here we create a new instance of an event emitter. Notice the syntax here. TypeScript supports generics. If you are not familiar with generics, this syntax allows us to identify a specific type that the object instance will work with. When creating an event emitter, the generic argument identifies the type of the event payload. If we want to pass a string value to the container in the event payload, we define string here. If we want to pass an integer, we define number here. If we want to pass multiple values, we can specify an object here. In this example, we define a notify event with a string payload. When the user clicks on the stars, the star component receives that click event. We use event binding in the star component template to call the star component's onClick method. In the onClick method, we use the notify event property and call its emit method to raise the notify event to the container. If we want to pass data in the event payload, we pass that data into the emit method. In this example, the onClick method raises the notify event and sets the event payload to a string message. The container component receives that event with the specified payload. In the container components template, we use event binding to bind to this notify event and call a method. We access the event payload using $event. The only time we can specify a nested components property as an event binding target on the left side of an equals is when that property is decorated with the output decorator. Lastly, the container component provides the method to execute when the notify event occurs. Since the event payload is a string, this function takes in a string. Here we can perform any desired action. Lots of moving parts here. Let's jump into the code and try it out. We are back in the sample application looking at the star component. We'll add output and event emitter to our import statement because we know we're going to need them, and we'll reformat the line so we can readily see it. We want to expose an event to the container, so let's define a rating clicked event property. We define the type of this property to be event emitter, and we want the event payload to be a string, so we specify string as the generic argument. We set the rating click property to a new instance of event emitter. We decorate this property with the output decorator to expose it so that the container can respond to this event. The output decorator is a function, so we add parentheses. In this example, we are decorating only one property of the nested component with the output decorator, but we are not limited to one. We can expose multiple output properties as needed. Moving to the template, we use event binding to bind the div elements click event to a local onClick method. Then let's implement this onClick method in the component. When the star component processes the click event on the div, it wants to raise an event to the container and pass along a message. We use the event property and call its emit method, passing in the desired string. In this example, we use the ES2015 backticks to define a template string. This allows us to embed the rating directly into this string using $syntax. Our star component is then complete. Now let's respond to this event in our container. The product list component wants to listen for this rating clicked event, so let's update the product list template. Here, in the nested components directive, we'll add event binding to respond to the rating click event exposed by the star component, and we'll get the event payload. We respond by calling our own local method. We'll call it onRatingClicked. The event payload is available using $event, so we pass that in to the onRatingClicked method. We then need to write code for this new method in the containers class. In the product list component, we define the onRatingClicked method. We'll add it on the bottom with our other methods. We define a message string parameter for the event payload. To keep things simple, we'll just modify the page title to display product list and the message from the nested component. Okay, yeah, that is not a very real-world example, but I wanted to keep this as straightforward as possible. We'd have a better example if the nested component contained an input box, and we could pass the user's input in the event payload. But you get the general idea here. Let's see how this works in the browser. We'll clear the filter by, click on the star rating, and we see the page title change to display the message received from the nested component. Success! We just saw how the container passes data to the nested component by binding to a nested component property that is decorated with the input decorator, and how the nested component uses an event property decorated with the output decorator to raise events. We can think of the properties decorated with the input or output decorators as the public API of the nestable component. Everything else in the component is encapsulated and only accessible to the component's template and class. Let's finish up this module with some checklists we can use as we build nestable components. We build a nested component using the same techniques we use to build any other Angular component. We won't review that again here. Let's instead lay out a checklist for inputs and outputs. Decorate a nested component property with the input decorator anytime it needs input data from its container. Any type of component property can be decorated with the input decorator. Don't forget the @ prefix, and since the input decorator is a function, follow it with open and closing parentheses. Decorate a nested component property with the output decorator anytime it needs to raise events and optionally pass information back to its container. Only properties of type event emitter should be marked with the output decorator. Use the event emitter's generic argument to specify the type of the event payload. and use the new keyword to create an instance of the event emitter. Don't forget the @ prefix, and since the output decorator is a function, suffix it with open and closing parentheses. In a Container Components template, use the nested component as a directive. For the name of the directive, see the Nested Components Selector property. Use property binding to pass data to the nested component. Any property of the nested component that is decorated with the input decorator can be used as a binding target. Use event binding to respond to events from the nested component. Any event that is decorated with the output decorator can be used as the binding target. And use $event to access the event payload passed from the nested component. This module was all about nested components. We began by building a component that could be nested within other components. We then walked through how to use the nested component within a container. We saw how to pass data into the nested component by binding to a property marked with the input decorator. And we discovered how to pass data out of the nested component by raising an event marked with the output decorator. In this module, we built the star component and nested it within the product list component. We can reuse this component in any other component of the application, such as the product detail component. Next up, let's check out how to build an Angular service so we won't need hard-coded product data in our component. Before we jump into building a service, let's take a look at how services and dependency injection work in Angular. In this diagram, our service is here, and our component that needs the service is here. There are two ways our component can work with this service. The component can create an instance of the service class and use it. That's simple, and it works. But the instance is local to the component, so we can't share data or other resources, and it will be more difficult to mock the service for testing. Alternatively, we can register the service with Angular. Angular then creates a single instance of the service class, called a singleton, and holds onto it. Specifically, Angular provides a built-in injector. We register our services with the Angular injector, which maintains a container of created service instances. The injector creates and manages the single instance, or singleton, of each registered service as required. In this example, the Angular injector is managing instances of 3 different services: log, math, and myService, which is abbreviated SVC. If our component needs a service, the component class defines the service as a dependency. The Angular injector then provides or injects the service class instance when the component class is instantiated. This process is called dependency injection. Since Angular manages the single instance, any data or logic in that instance is shared by all of the classes that use it. This technique is the recommended way to use services because it provides better management of service instances, it allows sharing of data in other resources, and it's easier to mock the services for testing purposes. Now let's look at a more formal definition of dependency injection. Dependency injection is a coding pattern in which a class receives the instances of objects it needs, called its dependencies, from an external source rather than creating them itself. In Angular, this external source is the Angular injector. Now that we've got a general idea of how services and dependency injection work in Angular, let's build a service. Are we ready to build a service? Here are the steps. Create the service class, define the metadata with the decorator, and import what we need. Look familiar? These are the same basic steps we followed to build our components and our custom pipe. Let's look at the code for a simple service. Here is the class. We export it so this service can be used from any other parts of the application. This class currently has one method, getProducts. This method returns an array of products. Next, we add a decorator for the service metadata. When building services, we often use the injectable decorator. This decorator is only really required here if the service itself has an injected dependency. However, it is recommended that every service class use the injectable decorator for clarity and consistency. Lastly, we import what we need, in this case, injectable. Now let's build our service. I've opened the folder for the sample application in the editor once again. Since our service will only provide product data, we'll add it to the Products folder. We'll create a new file and call it product.service.ts to follow our naming conventions. We're then ready to create the service class. I bet you can do it in your sleep by now. Export, class, and the class name. Since the service provides products, we'll call it Product Service. Next, we decorate the class with the injectable decorator, and we'll add the import statement for that decorator. As we discussed earlier, this decorator is optional, unless the service has an injected dependency of its own. But it is good practice to add it to every service, so we added it here. Now that we have the structure in place, we can add properties or methods to the class as needed. Unless marked private or protected, the properties and methods defined in the class are accessible to any class that uses this service. For our product service, we want a getProducts method that returns the list of products. We strongly type this return value using our iProduct interface, so we need to import this interface. In the next module, we'll see how to retrieve the products using HTTP. For now, we'll hard code them in here. If you're coding along, feel free to copy some products from the products.json file in the API Products folder. Notice that we have no properties defined in this class, so we are not using this particular service to share data. We are using it to encapsulate the data access features. By using this service to provide the list of products, we take the responsibility for managing the data away from the individual component. That makes it easier to modify or reuse this logic. So we're done with our service for now. How do we use it? Well, a service is just really an ordinary class until we register it with an Angular injector. Let's do that next. As illustrated in this diagram, we register the service with an Angular injector, and the injector provides the service instance to any class that defines it as a dependency. So what's actually involved with registering a service with the injector? To register a service, we must register a provider. A provider is code that can create or return a service, typically the service class itself. How do we register a provider? We define it as part of the component metadata. When we register a provider in the component's metadata, the Angular injector can inject the service into the component and any of its children. So we should register the provider at the appropriate level of the application component tree. If we register the provider for the product data service in the product list component, the Angular injector can inject the service into the product list component and any of its children. It could not inject the service into the product detail component unless we registered the provider again in the product detail component. Note that if we did register the provider for the service twice, we would no longer have a singleton. The Angular injector would manage two instances of the service, one for the product list component and its children, another for the product detail component and its children. If instead we register the provider in the root app component, the Angular injector can inject the service into any component of the application. Since we know the product detail component will also need the product data service, let's register it at the root. Here is the app component we built early on in this course. To register a provider that creates our service, we add the provider's property to the component decorator. The provider's property is an array, so we could register multiple providers. To register a provider for our product service, we specify product service here and import it here. Let's do that now. Here is the app component. In the metadata, we'll add the provider's property and specify our product service. So we of course need to import our product service. An instance of the product service is then available for injection in the app component or any of its child components. Now we can specify where we need the service to be injected. Here again is our diagram. In the last clip, we saw how to register the service with the Angular injector. Now we just need to define it as a dependency, so the injector will provide the instance and the classes that need it. So, how do we do dependency injection in Angular? Well, the better question is, how do we do dependency injection in TypeScript? The answer is, in the constructor. Every class has a constructor that is executed when an instance of the class is created. If there is no explicit constructor defined for the class, an implicit constructor is used. So far, we have not needed an explicit class constructor, but if we want to inject dependencies, such as an instance of a service, we need an explicit constructor. In TypeScript, a constructor is defined with a constructor function. What type of code normally goes into the constructor function? As little as possible. Since the constructor function is executed when the component is created, it is primarily used for initialization and not for code that has side effects or takes time to execute. We identify our dependencies by specifying them as parameters to the constructor function, like this. Here we define a private variable to hold the injected service instance. We create another variable as the constructor parameter. When this class is constructed, the Angular injector sets this parameter to the injected instance of the requested service. We then assign the injected service instance to our local variable. We can then use this variable anywhere in our class to access service properties or methods. This is such a common pattern that TypeScript defined a shorthand syntax for all of this code. We simply add the accessor keyword, such as private here, to the constructor parameter. Then this is a shortcut for declaring this variable, defining a parameter, and setting the variable to the parameter. Neat! You'll see this technique used throughout the Angular documentation and other code examples. Ready to give it a try? We want to use our service to get products in the product list component. So we'll define our product service as a dependency in the product list component. We don't have to add the providers array here because the product service is already registered in the app component, which is the parent of this component. All we need is a constructor. The constructor is normally defined after all the properties, so we'll add it here. We'll use the shorthand syntax to define the dependency, private underscore product service. We use an underscore here to denote that this is a private variable. Then, because we are using TypeScript, we type colon and the type, which is product service. Note that the accessor doesn't have to be private. This shorthand syntax works with public and protected as well. So now we have a syntax error here. I bet you know why. Yep, we need to import product service so we can use it as the data type here. Now, when an instance of the product list component is created, the Angular injector injects in the instance of the product service. We are at the point now where we can actually use the product service. First, let's delete the hard-coded products from here. We'll instead get them from the service. Now the question is, where should we put the code to call the service? One thought might be to put it in the constructor. But ultimately, our product service will go out to a back-end server to get the data. We don't want all of that executed in the constructor. Other thoughts? Remember our discussion about lifecycle hooks? Earlier in this course, we said that the on-init lifecycle hook provides a place to perform any component initialization, and it's a great place to retrieve the data for the template. Let's use the on-init lifecycle hook. We want to set the product's property to the products returned from our service. To call the service, we use our private variable containing the injected server instance, this $_product service. We then type a dot and the name of the method we want to call. Notice how IntelliSense helps us with all of this. Let's make one more little change. Let's remove the default list filter value so we'll see all of the products in the list. We should be all set to see our result in the browser. And here are our products. Yay! Notice that we have more products displayed now because I hard-coded more products into the service. Let's finish up this module with some checklists we can use as we build our services. We build a service using the same techniques as when we build components and custom pipes. We start by creating the service class. We specify a clear class name appropriate for the services it provides. Use Pascal casing where each word of the name is capitalized. Append service to the name, and don't forget the export keyword. We then decorate the service class with the injectable decorator. Don't forget the @ prefix, and since the decorator is a function, follow it with open and closing parentheses. This particular decorator is not always required, but it is a good practice to add it. And be sure to define the appropriate imports. The first step to registering the service is to select the appropriate level in the component hierarchy that the service should be registered. Use the root app component if the service is shared throughout the application. If only one component needs the service, register it directly within that component. Otherwise, select a common ancestor of the components that need the service. In the selected component's metadata, use the provider's property to register the service. Pass the service provider as an element of an array, and be sure to define the appropriate imports. In any class that needs the service, specify the service as a dependency. Use a constructor parameter to define the dependency. The Angular injector will inject an instance of the service when the component is instantiated. This module was all about services. We began with an overview of how services and dependency injection work in Angular. Then we walked through how to build a simple service. We defined how and where to register the service with Angular, and we examined how to define the service as a dependency